Okay, so I forgot to start the recording, so you're just going to have to catch up if you're listening online. We're starting with the limiting reagent, which we found out was HBr, so moles of HBr. And we're going to use the coefficients 6 and 3 to go from moles of HBr to moles of H2. I want to get rid of moles of HBr, so 6 moles of HBr go on the bottom. I want to get 2 moles of H2, so that goes on top. Moles of HBr go out. I take 4.96, times it by 3, divide by 6, which is basically just dividing it by 2. And we're going to get 2 point what? Moles of H2. If you haven't got a calculator out, you're going to want one out. If you haven't got a periodic table out, you probably want that out. So somebody do that calculation for me real quick. 2.48. Okay. Now, this bottom one here, for the reactant in excess. So the excess reactant is aluminum. Okay? It's aluminum. How many moles are left over at the end of the reaction? So I'm going to need to take my limiting, which one I'm going to need, and find out how much aluminum is going to be used. So I start again with my limiting, which is 4.96 moles, and I'm writing it above because it's too hard to squish down, of HBr. This time, though, I'm going to be going from the 6 to the 2. So I'm going to go 6 moles HBr on the bottom because I still want to get rid of it, and 2 moles of aluminum on the top. Moles of HBr go out. So this time I'm basically dividing it by 3, so it's going to be 1 point something moles of aluminum that are used. So somebody give me that number. 1.65. Okay, 1.65, we'll just go with that. I started with 3.22 moles of aluminum, right? So I just need to subtract that to find out how many moles of aluminum are excess. Does somebody have that done? 1.57. Okay, so as an industrial person, if I'm out in industry, I don't want to waste product, and that, by putting those two things together, would waste product. I would waste 1.57 moles of aluminum. Okay, I don't want to waste that much. So we'd need to rework that. Okay, so for the next one, okay, this one right here, let's look at this one. So on this one, we've got 21.44 moles of silicon, and we have 17.62 moles of nitrogen, and they want to find out how many moles of trisilicon tetranitride there are. Okay? Well, it's a 3 to 2. I don't know about you, but I know I have more silicon than I do nitrogen, but I don't know if it's a 3 to 2 ratio off the top of my head. So because I don't know for sure, I'm just going to take, and it doesn't matter which one you do, I'm just going to take the first one, 21.44 moles of silicon, and I'm just going to do that quick conversion. So for every 3 moles of silicon, there are 2 moles of nitrogen. Moles of silicon would go out. I would take and times that, divide it, what do I get? Should be like 14 point something. 29 moles of nitrogen. Now, that's smaller than what I have, right? So that tells me that silicon is my limiting reagent. That's the one I'm going to run out of first. Now, I can take my silicon now. It's 21.44 moles of silicon. And I'm going to convert it this time from silicon to the trisilicon tetranitride. So I'm going to put 3 moles of silicon on the bottom, and I'll put 1 mole of Si3N4 on the top. Moles of silicon go out. So I'm going to take 21.44 divided by 3. I'll end up with 7 point something. Somebody give me the numbers as my answer. 1.5? Okay. All right, now they want to know again the excess. So the excess here is the N2 that we're trying to find. How many moles are left over? So again, I'm going to start with my known, my limiting, 21.44 moles of silicon. This time I'm going from here to here. So I'm going to go 3 moles of silicon for every 2 moles of nitrogen. Moles of silicon go out. Take that and times it by 2 and divide it by 3. So it'll be in the teens. What do we get? This is how much we used. So 14.29. Oh, we've got that up there. We already did that. Hello. See, I'm already focused on this. I already did that work. I didn't have to redo that. Okay, so then we just take what we had, 6.2 moles that we were given, subtract them, and this is the excess. Moles of nitrogen, which would be 333. Is that right? Okay. So not too hard, right? We okay so far? Okay, let's do this one. I want you to do it all on your own. Practice, all on your own. See if you can do it, and then I'll put it up. If you have questions, let me know. Give you a few minutes head start. I wonder if you need help, let me know. You can do that, or you can just look and say both of these can be divided by 2, right? Mm-hmm. So it's a 1-to-2 ratio. So for every one of these, I need twice as much of this. Do I have it? So if I take that and times it by 2, do I have that over here? No. So this is going to be my excess. That'll be my limiting. That's all I need to know. Okay. Let's move on. So don't look up until you've got it or you're stuck, one of the two. Okay, how do we do? Not too hard? Getting this? Okay, so they can actually not give you moles. They could give you grams to start with. Just remember you got to change it into moles before you use the equation. I know. Okay, so you got to change it into moles before you use the equation. But the same kind of thing would go on. If they ask how much was left over in grams, we would take the mole to gram. Okay, so there's that. Okay, we got another one. I want to see if you can do this one all by a little lonesome. Some of you were stuck on the last one and I helped you. So see if you can do this one all on your little lonesome. If you need help, please let me come in and help you. That's an S. Okay, how do we do on that one? Are we getting this? Do we understand what to do each step? Is there a step that I need to go back and talk to you about? Are you okay? We getting this? Don't be afraid to ask. This is your grade. Okay, so now, after this, with stoichiometry, the last thing that we need to use is reaction yields. And this is easy. If you ever found your percent on a test, this is what it is. Okay, reaction yields. It's just actual yield. In other words, what did you get on the test divided by what you should have got on the test or what you wish you got on the test, the total possible. Okay, and then times it by 100. So if it's nice, they just do this. The actual yield was this. You should have got this. What's your percent yield? So you're just going to take 11.74 divided by 16.09 times it by 100, and you end up with your percent. We usually report percent to 2 after the decimal. So when we're in industry, we want a percent yield of 80% or better. If we're not getting 80% or better yield, then your supervisor is probably going to look at cutting your pay. Okay, so let's see what this is. Is this person going to get a cut in pay, or is this person going to get a raise? Going to get cut. So what is this? What is the percent? 72.96. Yeah, cut and pay. All right, so let's go to the next one. Okay, see if you can calculate that top one. We're going to do the bottom one together because it's a little bit hairier. So tell me the top one real quick on what you need to do. So read through it, figure out what you need to pull, and what goes where. By the way, if you also get above 100% yield, you're also fired. Why? Over 100% yield? Not possible. You've done something weird. Okay, so what did this guy get for a percent yield? Should have done 308 divided by 323 times by 100. What did we get? Is this guy going to be kept his job, or is he going to get kicked out? 95.36. He might even be up for a raise. Okay, so now in the bottom one, you'll notice that it's a little bit different here. The reaction started with 384 grams of S6. Assume an unlimited supply of oxygen. What is the theoretical predicted yield? So I have to find out what the yield is. And the percent yield if only this much sulfur dioxide was produced. So what's the first thing you think I need to make or do? I've got to have a balanced equation, guys. That's the first thing. So they started with S6. Okay, and they added to it an unlimited supply of oxygen. So how do I write oxygen in an equation? O2. It's one of Braun-Hifkel. Good. And I could put the solid there, and this would be a gas, and I get sulfur dioxide. What is sulfur dioxide? SO2, and it is also a gas. Okay, is it balanced? What do I need to do to balance it? Six where? You guys are so talkative. There and there. Okay, so they gave me that I started right here with 384 grams of this. I need to find out how many grams of this that I have. So this is straight stoke that I'm doing right now, just straight stoichiometry. So I know I'm going to have to add up SO2. So let's just do that really quick. So we've got sulfur at 32.06, and we've got two oxygens at 15.999. And I know I'm going to have to add it up because they want it in grams, right? So let's add that up real quick. What do we get? Zero what? 96? 58. Okay. That's grams per mole of sulfur dioxide. Okay, so we're always going to start when we do stoichiometry with what they gave us, which was the 384 grams of sulfur. I didn't add up that one, even though it's 6 of them, because in the bottom I can just go 6 times 32.06 would be the grams of S6 in 1 mole of S6. So I didn't really need to do that ahead of time. Grams of S6 cancel out. Once I've got to moles, then I can go back up to the equation. At the equation, I'm looking at the coefficients between the two that I want to trade between. I want to get rid of S6, so it's going to go on the bottom, 1 mole S6 on the bottom. On the top, I'm going to put 6 moles of SO2. At this point, mole of S6 goes out. Then I'm going to use what we just added up, and I'm going to put 1 mole of SO2 on the bottom, and I'm going to put the 60, I'm going to make that a 6. We're going to make that a scribble, 64.058 grams of SO2 on the top. Moles go out. When I put this in, I need to make sure that when I put this in the bottom and hit my divide, I do a parenthesis and a parenthesis. Let's get the answer. This is my theoretical. This is what I should have produced. So is it going to be bigger or less than the 680 that I did produce? Is it going to be bigger or less than? Better be bigger than. If it's less than, then I'm over 100%, which is not good. So I should be above 680. What is it? 700 and something. So 384 times 6 times 64.058 divided by parenthesis 6 times 32.06. Close parenthesis. Enter. We'll just use 3 significant figures. We got one? What you got? Okay, good. Grams of SO2, right? So in order to get the percent now, we're going to take that number right here, 680, divide it by 767, times it by 100, and we're going to get our percent. Is this person getting fired? Or are they keeping their job? They're good? What did they get percentage-wise? 0.63%. That's what I got. I don't know if we get that or not. Okay, so they would keep their job. I kept the number in there, but I used the whole number. Okay, so you need to be able to do that. Okay, so the first ones were simple, easy, but you are using now a whole bunch of things. They want to see if you can do it all together. So it's the Stoke, it's writing the equation, it's balancing the equation, it's doing the percent yield. Okay? All right. So that's the end of what you have to do for this chapter. Okay, so I like the Mentos and Coke thing. That's pretty awesome. I like the guys in the background. It's awesome. Okay, so Monday tutorial. We're going to do review. Wednesday after school, more review if you need it, or anytime before after school if you need extra help. Okay, so what we're going to do today is we're going to actually take a